How you been, George?
I'm doing well. Thank you for asking.
Thank you for joining the session. We are so excited for having you here.
Oh,
And
well,
please tell us, how are you feeling today?
I'm feeling great. So it's this has been a neat project to be involved in so far, and it's otherwise a lovely day here in Chicago. So it's happy to pitch in how I can, and excited to meet some new people. So how's it been going for you?
Great. It's we were having the opening ceremony in the last couple of days, and
Hmm.
it went really good because we were having some friends there in the university, and we have some guests from other institutions. So we really had a good time.
Excellent.
Mm.
I love to hear that. So, what's been your favorite topic or what's been the most interesting talk that you've been a part of so far?
Well, there in the inauguration, we were checking out the roadmap about
Hmm.
what we were doing and what it has to be done. So that's exciting to hear because there's a lot of work and a lot of projects coming in. So it looks interesting. Well,
Awesome.
so I am I was reading your bio and your
Yeah.
abstract, and yeah, I am excited to listen to you. So
Well, thank you. I'm excited to talk and meet some new people. So, especially folks that are interested in such a complicated topic um, so early in their career too. But my topic today isn't complicated. So,
but okay. So I think we are going to start a little bit earlier because sometimes we don't have enough time for questions. So maybe we should start by now. I'm going to introduce you
okay.
and to the audience. So, George Dill, um, you have an engineering and computer science students, and you have built much of their portfolio for the purpose of demonstrating mastery of individual learning objectives. As the scope of a software project grows from demonstrating personal learning to producing novel research or commercial products, teamwork becomes critical to meeting that project objectives. The introduction of new tools, design patterns, a loss of control that comes with the transition to collaborative work can be jarring. To prepare students for this pivot, we will introduce popular collaboration and automation tools, typical software architecture patterns that allow the teams to work in parallel, and strategies for building consensus on a software project engineering team. So that was the abstract of the presentation we're having today. And I'm going to read a little bit about your career. George Dill is a software engineer and founder of Abundalian Software LLC. Abundalian is a software consultancy focused on helping research projects scale through modern cloud architectures and project management. George, George has collaboratively built full stack cloud native applications for firms including John Deere and Eco Global Logistics. Prior to that, George earned a master's degree in computer science from the University of Illinois. at Chicago, where he loved interdisciplinary design and devising clever work assignments. George still lives in Chicago, where his interests include the White Sox and programming in JavaScript. Thank you again, George, for joining me, and the audience is George. So,
Excellent. Well, thank you for the warm introduction, Juan Carlos.
eh, thank you
I,
for your time.
all right, so let me share my screen. We're going to get an echo while I pull up Keynote. All right. Excellent. So just wanted to confirm, Juan Carlos, you can see my screen, yeah?
Yes, yes, we can see your screen, George.
Excellent. So um, we've got a small group here, and I'm excited to be speaking with you all. And since we're so small, I'd like to open it up to if you see something while we're talking and you have a question about it, like feel free to raise your hand and or put something in the chat. And Juan Carlos, if you're watching the chat and you see something that I'm missing, feel free to call it out. Um, but good afternoon and buenos tardes. I'm George. Juan Carlos did a great job introducing me, but I am the founder of Avondalian Software, which is my consultancy that we are focused on bringing research projects to production. And the first one I'm working on is here with Braulio and trying to bring the Q Composer onto AWS and have it scale so that it can be used for a wide variety of students in Latin America. So this is a pretty exciting first project to be involved in. Um, that said, today's discussion is not so technical as it is about providing some tips and an exposure to some software tools that were important to me as we as I transitioned from being a student to being a professional working in enterprise, but would also be applicable to really any kind of product team, whether that's your own small business or working in a research group. Um, so with that, I'd like to let you guys know what I plan to talk about. So in case you already know this stuff, you can bounce out, get a snack, get ready for the hackathon. So today, some of the stuff that I'm going to bring. Um, One, I want to describe that there's a mindset shift that you undergo as you graduate from being a student to being a collaborator on a project-based team. Um, Once you pivoted from this homework mindset to the product mindset, um, there's going to be different strategies that you need to deliver your product and work with your team. Um, as we talk about that teamwork later, we're going to then do a cursory survey over software collaboration tools and have a lightweight demonstration showing how modern version control tools and CI/CD pipelines can speed your product's path to production. And then at the end, I want to go over some real software focused stuff. And at a high level, we're going to talk about tips for authoring your software so that you can manage the constant change that we experience in a shared code base. And why you should listen to me. Besides starting the small company, and as Juan Carlos mentioned, I've been working as a software engineer since 2020. I've worked for a couple large firms here in Chicago. I have a master's degree in computer science, which I'm sure a lot of you do too. And I've also worked in a lot of serious project management work. So I've been involved in major oil and construction projects um, in Texas and in South Korea, which was pretty cool. And so if you want to talk differences in project management styles, that's also a fun topic I like to talk about. But you can ask me about pizza and Chicago sports. And I've also started a hobby of relief printmaking recently. So just a little flavor. Um, cool. So just, I don't know if we have a chat or a show of hands or anything, but are most of the folks in the room students? I'm going to assume yes. Oh, I see the chat now. Well, anyway, I wanted to talk about a topic. I wanted to open first with what I think is the most important topic of transitioning in your career from being a student to being a professional. Um, and it's this mindset shift of moving away from everything being homework to being collaborative um, participation on a team. And I'd like to explain that a little bit more in detail. Oh, man. Okay. So, at least in the United States, a student's journey is from the beginning 6 to 8 hours a day of drilling facts and taking tasks to demonstrate mastery. I mean, my daughter's 14 months old, and daycare is sending notices of like, oh, she's past this milestone of being able to dance to music. Like, she's just a year old, and we're already like have homework for her. um, so as a student, you learn to read, you drill flashcards, you read books with the purposes of filling out homework assignments and writing essays. And so your journey for this first 20 to 22 years of life is uh, doing work to demonstrate individual mastery, right? Like homework is it's work you deliver to show that you know how to do it. It's testing all the way up the line. Um, so great, you've mastered course material. But the most important piece of advice I'm going to offer for you today is that as you transfer into a research project or as you transfer into the enterprise environment, um, the collaboration is the opposite of homework. Like you have a team. After you graduate, any environment that you enter is going to be focused on building a product. And it might be a quantum computer or it might be an algorithm or a website. But either way, to be the first to market, you're going to have to work with others to accomplish the group objective. And all of the stuff that you've learned to date about academic honesty and focusing on individual mastery is going to go out the window because your loyalties now align with your team and finishing the thing that you're building on. So, and as I was putting this together this week, I was thinking of famous teams, and the Dodgers won the World Series. So I don't know if there's any other baseball fans out here, but that was on my mind. We got a famous team. So we've decided we're not doing homework anymore and we're working together on a team. Like, how do you make that work? What kind of personal habits do you need to change? And I think the first one that's important is being vulnerable. When you don't know something, like the best thing to do is ask. Your teammates want to help you accomplish your goals. And if you find yourself like on a task and you don't know what to do with it for more than a couple hours, like that's the time that you should be reaching out and asking for help, right? When I'm working on homework and I'm jamming on it all night because like I got to figure this out. I need to internalize this. I need to be able to regurgitate this on an exam. You don't have that anymore in a project environment. So ask your teammates to help. They want to help. They want to make sure that everything is going in a direction that they can support together, which is a reason why you should also over communicate your progress. Um, people want to know how you're doing, and people also want the opportunity to provide early feedback. You might think you're on the right track with your project, and then a colleague's going to say that and say, "Hey, we actually already programmed that, and you should use this class." Or there's a framework that does this, and so then we can make that and not have to test it. So your colleagues can provide those insights to you if you're vocal about where you are and what you need help with. So on the inverse of that coin, when your teammates are reaching out for help, be available to them, right? Be on your team's group chat, Slack, Teams, or whatever you're using, WhatsApp. But however your team is communicating, be there and don't let their requests for review or help languish all day long. Like jump on a call with them and look over their shoulder and try to figure out problems together. I think all of you in this room have spent a lot of time growing your skills, and everybody's got a unique skill set, and you may have that magic sauce that helps fix the problem. And the last of that is always be open to learning something new. Um, I've been doing this. I've been doing this professional programming for 5 years, 6 years, and already since I've been doing this, the front end frameworks that are popular have completely changed. And if you're not open to learning where the new trends are or why they're becoming trends, you can get left behind pretty quickly. So always be open to learning new things or trying things a different way. Um, yeah. So with that, I that's a natural breaking point. I'm curious if there's anybody wants to talk about that mindset shift, or if that makes any sense, or has any questions about that period before we go into what the day in the life of a software engineer looks like. And Juan Carlos, I see 3 items in the chat, but I can't get to them to read them. Um, so if there's comments in there that I'm missing, could you read them out?
Yes, of course. The first one is mine. When you um, were talking to me, I replied, of course, because I was already closing my microphone and my camera. And
Mm,
the second one is about that the audience can make the questions here in the chat box. So it's a little reminder that it's there.
okay,
And the last one is Sebastian. And he replied, yes, I think he was um, replying that we could see your screen in the
excellent. Okay,
presentation. Yes, don't worry.
all right. Okay, so well, if there's no questions, I'll just keep moving along. So, all right. So at this point, we've established you're working on a project team. You're committed to producing something. But I want to talk about how it looks like to be working with your colleagues to get something done. Um, and the next slide, we're going to talk about agile. And to focus that conversation, I want to talk about kind of classical project management for a second, where you might be tempted to plan a project um, because we've got 5 people and we're working on something together. And it makes sense to find every opportunity for us to work in parallel. And so we're going to plan how we're going to execute this project from start to finish 100%. And we'll have a big, massive release at the end where we show our product to the world. And it's really tempting to just plan and plan. It's like, I don't know, you're starting a band and you think of an awesome name before you actually start writing any music, right? You can plan and you can really get caught up in the effort of planning, and that's also near and dear to my heart from the construction industry experience. But for software, the best way comes from a group of guys that wrote what's called the Agile Manifesto, and this movement started about 20 years ago. And it's a kind of reaction to the meticulously planned and poorly executed software projects that came before it. I really recommend checking out agilemanifesto.org. It's a short read, and the authors are real heavy hitters and thought leaders in the industry. But in summary, the manifesto asserts that software teams run at their best when there's open communication between engineers and project stakeholders, and when working software is delivered in regular increments. And that's a huge mindset shift, right? As we're doing homework, you finish your project and you turn it in. Like here, we're constantly getting feedback and delivering a little bit at a time. And when you have a team culture that supports open communication and constantly delivering small units of correct software, you're better able to do that communication because your customer, your PI, your mentor, whoever you're working with, can see what you're up to and provide you guidance to redirect right away. So all of these 4 topics together really come together in communicating early and often, producing just a little bit at a time, and being able to pivot and respond to change. Um, I've got a story about how this has gone wrong. I was having coffee with a colleague of mine the other day, and he told me a story about how he hired a young consultant to build a website for him. He was trying to engage the consultant into regular meetings, and the consultant never really took them or shared as work in progress. And a long period of time later, like 2 months later, the consultant's like, "Hey, I'm ready to show you my work." And the product was so different from what they had spec'd out that they decided just to cut them loose. So it's, it was a relationship where the client was actually really trying to even mentor the young consultant, and it wasn't working out because he was doing homework, he wasn't doing a project. So so regular progress checks could have prevented that situation, and probably would have had the website up sooner because you can have one page. You can start implementing features and building on top of a foundation that you've put together rather than coming out with everything all at once and having a static artifact. All right, next. So with that, I kind of want to talk over just what is on a typical software team. You step into that office, and there's three roles that kind of emerge when you're on this software team, and different people may take on multiple of these roles, or some of these roles may be split out to different folks. But regularly, the people you should be meeting with on this project are going to be a product owner, and this person is the voice of the customer, or could be the customer directly. But this person makes decision on what is going to go into the software, but not necessarily how to build it. Um, but they are going to know how many people might be using it at the same time, or how long they need to retain data, or this is a person that you can ask for question when you have questions about specifics of the software. Like, you can ask them how a user is going to use this type of software. Um, and they provide feedback while you're building. So you should be meeting with this person on a regular cadence, weekly, maybe bi-weekly, just to show them what you've done. And they accept that finished product. So, and then most of the folks in this room, I would assume, are going to come in as engineers. Um, this group actually does the building. They're going to plan how they might implement a feature. So they're going to sketch out how different modules of the software might talk to each other, how they might deploy it onto the servers. Um, they're going to implement the work, and then they're going to test it. And sometimes that's a different position, but it's not always. Um, and they can also talk to the product owner about features that might add value. They may be asking for a feature that is actually a larger effort than they think that it might be. All right, everybody's asking for chatbots right now. But if you ask about the user journey, you might actually say, "Hey, I can build this other thing in 3 days versus 3 months. Like, let's try that out first and see if it's getting the results you want." So you can always, I wouldn't say push back so much as provide recommendations. Um, and then depending on your situation, you might have like an engineering manager that navigates some of the corporate world around you. They may provide guidance on software architecture or corporate standards, communicating the project status to stakeholders. And that's also somebody you should be able to look up to as a mentor. So if you're interviewing and you're interviewing who might be your engineering manager, and you're looking for somebody that you think that you can get along with and learn from, so ask them questions that make sure that that's the kind of person you want to be in a relationship with. So I don't know if anybody in the room has heard of Scrum, which is kind of they call it a framework or an operating framework, but it's kind of a thing that consultants come around and sell. But they advocate a fourth position that I've rolled into the engineering manager's duty called Scrum Master. And this person's typically a meeting facilitator and like metrics reporter. Um, but smaller teams don't really need all that overhead. So part of that then is, you've got all these teammates. As an engineer, what are you going to do with your day? And I would advocate coordinating with your teammates daily, letting them know what tasks that you've completed, what tasks you're needing help completing. Usually that this can be, if you work in person together, this can be a meeting over coffee where you just all stand around somebody's desks and say what you're working on. Online, I'm going to introduce you to Kanban boards here in a second, but online, a lot of that kind of looks focused around this Kanban board tool. Um, as you're starting to work on something and as you're working on something and then you realize you didn't ask all the questions you needed to at the beginning, you might find yourself clarifying business requirements, opening that direct line to the product owner and asking them about how they might use something that you didn't quite understand when you got started. You may find yourself planning a feature, like just because we're not planning everything in detail from the very beginning of the project doesn't mean that once we pick something off the shelf to start working on, you want to have a strategy for completing it. You don't want to just be kind of um, going by the seat of your pants working on that. And you review your friend's code, your colleague's code. You write tests if that's what your organization does. You write your own code, and you should be demonstrating your work in progress pretty regularly as well. Uh, with that, when you're working specifically with other engineers, there's a couple of strategies that are popular, and I've used all of these. And we've already gone over this, some of it, but folks will talk about pair programming. Some organizations have two developers always working on a task together. That's not the way I like to run, but it's a thing, and you should ask about it if you're in interviews. But that's, just looking over your partner's shoulder and talking about problems as you're working on them. This is done asynchronously as well through a tool called pull requests, and we're going to demo this later. But it's like an online form which shows the difference in the code, and your colleagues can comment on that and suggest changes. You should just be talking to people daily, and if you're not in person and just having lunch conversations and coffee, and I guess I talk about food a lot. But if you're not having those regular conversations, you should also be on your messaging apps having those conversations too, being active in your group channels. Um, with that, that's the end of what I wanted to talk. That's more on the soft skills, and wanted to start getting more into some of the collaboration tools that are available, and some of what I would think are the bare minimum for starting a project. So it seems like a good time to take a break or pause and see if folks have any questions.
Yeah.
Yeah.
So far, we have a few questions on the chat. So I don't know if you will like to listen them.
Yeah, please read them out.
Okay. So George, Daniel says you work with both big corporations and small research teams. What was the most challenging collaboration experience you have had, and what did it teach you about teamwork?
That's a great question. I'll tell you, the most challenging collaboration, um, the biggest challenges I've always had to collaboration have less to do with the technical work and more to deal with organizational politics. And um, and it always seems to come down to trying to be nice, um, but also um, being being a contributor. Like you've got to always be helpful, but um, sometimes you have to kind of watch out for folks that might be trying to take a free ride off of you. So, um, I'm here talking about the perfect team. But I do think that it's important as you're looking to join a project is when you're in that interview, and that might be like I've had thoughts about maybe trying to enter a PhD program or trying to interview to join a project team, like it's important that as you're feeling each other out, that you ask that team what their established ways of collaborating are and making sure that that's going to fit with your style. So, um, yeah, it's always the personal stuff more than it is the tech stuff. And I think that's the thing that a lot of engineers, a lot of people go into this because they think that maybe it's a thing where I don't have to communicate so often, or I can just kind of keep to myself. And it's always best to be more open. You don't have to be chatty, but you need to be more open.
Okay, thank you. Following, when you first started working in collaborative projects, what was something you wish someone had told you earlier about managing code, communication, or expectations?
Oh, yeah. I said that this is near and dear to my heart. I when I first started working, I was working at a at an oil company, and I was um, traveling a lot. I was going out to um, these terminals where we would load the trucks up with the fuel to then take to the gas station and sell them. And I was out at these facilities, doing little projects like welding handrails on things like. Um, but I always really struggled to get good assignments. Like I was always just doing like work that was far away and time consuming, but never really appreciated. And um, about 2 years into this job, um, I was I kind of tucked in next to like a much more senior engineer, and I was like, "Hey, man, like you seem to have the goods. What am I missing here?" And he's like, "You're not." He's like, "You don't talk to your boss. You never you haven't talked to you don't talk to your engineering manager. You should be in that guy's office weekly, letting him know what you're up to, asking for feedback, looking for help." And my fortune turned around as soon as I was like, I want this meeting. Here's what I'm bringing. These are my goals. Like, um, in short order there, I went from having lousy work to having actually like career making work and being asked if I wanted to take a promotion. So that that's the biggest piece of advice, and that's why I opened with that is like you don't have to struggle in any of the work you're doing alone. And actually everybody wants to hear what you're up to, and it can only help you if you're going to communicate that out.
So sweet. Okay, yeah. Hyde asks, was there a specific moment or project that made you realize I love building things with a team? If a Mexican student came to you saying I want to build something real, but I don't know where to start, what would your first piece of advice be?
Yeah, I hear two questions there. Like first off,
Yeah,
like when
yeah. I
when
just
did
read two
you
together.
yeah when did you realize that this is the thing that you want to do for a living, or like confirm that this is the thing you want to do for a living and you love working on a team? And then the second thing would be how to get started.
Yes.
Yeah, so the first one was after I graduated at UIC, my master's thesis work was I worked pretty frequently with my advisor, but I was working mostly solo code development. And I joined a consultancy in Chicago that was working with Echo Global Logistics. That's the one I called out on my resume. I was paired together with two guys that are still my best friends in Chicago. And we were really focused on solving problems, um, learning how to use the programming languages that were in the company's tech stack, and um, we just had like a supportive environment back and forth, and we talked every day about where our problems were. Um, we traded resources with each other, like, hey, you're trying to learn how to do this work on the front end, I have this book. You should read it. Like, um, um, my friend, my friend taught me how to use Kubernetes, and he used containerization to upgrade all of the software in short order and saved the company from weeks of downtime after they had a security incident. So seeing how high functioning that team was working because we had the freedom to identify problems and solve them, and then we were communicating well with each other. Um, that's the kind of collaboration that I'm continuing to seek. As for getting started,
Mm-hmm.
there's so many different ways that you could get started. Part of them right now, like I I'm helping with Q Composer just because I met Sandra Guessing and she's like, "Oh, I know this cool project and I'm involved in it and we could use more hands." Like and that was and then
Always, yeah.
she introduced me to Braulio and that's how we got started. So I found something that I was interested in and asked if I could help. Um, I think there's all sorts of ways you could apply for a job if you're in the university and you are planning to stay a little longer, like go meet professors that are doing research projects that you're interested in and see if they have work. Um, People always say join an open source project, which I don't know if I've ever known anybody to actually do that, but that's out there. And um, also, like, if you have friends that are in the program together with you, like, build something that you're interested in. Like, so many dudes are interested in trading sneakers. Like, build a sneaker trading site and just learn. We say gym shoes in Chicago, by the way. Just learn uh, how to build an e-commerce site or how to work it with a front end framework or how to host. Like, there's so many opportunities out there, um, and it's about try to find your tribe and work with them. And the only way you find them is by asking.
Yeah, always best way. Ask.
Yeah.
So, speaking about questions, Sarah is asking, what kind of mindset or work ethic do you think separates good coders from great collaborators?
That's a good question. And I don't think that obviously there's a Venn diagram there, right? Where they, you know, you can be both. I I think, you know, good coders are good collaborators. Um, Obviously there are some folks that go out there and they build a product on their own and they launch it and that get that is our Silicon Valley myth, right? But I I think even once you have to collaborate in some way to even identify the product that it is that you want to build. Like you you are exposing yourself to ideas to come up with a product idea and to synthesize those needs that you see in the environment and then bring them together and to say like this is something that I can build. I think good coders, besides being curious about trying to solve the business need, but the craft of actually coding itself, I think it's like going to the gym and lifting weights, right? You have to go out and do it over and over and over again. And and the more you flex that muscle, the more you're going to learn um, the corner cases that you don't see in the Hello World tutorials. And as you expose yourself to those, they'll make you stronger every time. So I think just being a good coder, besides being able to capture information, comes from practice. Um, And if that's all
Yeah.
the questions, we can talk about some of the things you should be practicing.
Well, there's another question. We have several
Yeah,
questions.
we've got plenty of time. Let's hear them.
Yeah, absolutely. And I think you're going to like this one.
Okay.
So, you've taught and mentored students before. What qualities do you see in the most successful young developers that others could try to emulate?
Guys that read and not expect, sorry, in Chicago, we use guys without a gender. But people who read um, are, I think, and people who actually build are, I think, the folks that succeed the most. I think sometimes a young person or an inexperienced person might be afraid of showing mistakes. And instead of getting out and actually building or showing curiosity in what they're building, they hide. And that's a doom spiral. So I think reading and doing um, that bias for action are the signs in somebody who's going to perform well.
Wow, interesting. Okay, following question. Responding to change over following a plan can lead to never finishing a project or going back and forth rebuilding things. How can you handle this?
I love that question. When you are running a website, um, that that online service itself, until it's deprecated, until you take it down, is running. and and it may have run yesterday, and today we've had a security vulnerability introduced into something in our tech stack. And if I leave that sucker up, I have to change it anyway. I mean, like I may have somebody take over my server, and then you don't know what they're going to do with your server once they take it over, and it's probably something illegal. I mean, best case, they're sending spammy emails, but it's in you don't know what they're going to do, and you can get in trouble for that. So, um, projects are never done. Um, they might be into a maintenance mode, but they're never done. And I think that that's where a lot of the agile frameworks come into play. Like you start a project, you do need to, like even your most basic websites, to get them up and hosting. If you're working on it, maybe like on a two-person team, it takes like 2 weeks. Um, so you're not going to deliver that incremental. You'll start delivering that incremental progress a little bit later. Where was I going with that? Um, and then if it changes underneath you, like you got paid for it. So so do what they ask you to do and just change it to what they're asking for. So hopefully you got paid for it.
Yeah, no
Yeah.
complaints. Okay.
Yeah. If the check cashes, if
Yeah.
you're, and if maybe you're working on research, like not all research supports your hypothesis. You may put an experiment together and it doesn't work. That may not be a paper, but it's at least worth noting, trying to figure out why it went wrong, talking to your PI, and that's part of your development too. Talking from somebody who doesn't have a PhD, but I would assume that that's also important. So
Yeah, for sure.
failures,
Mhm.
failures, failures are part of the process.
Yes, definitely. Okay, next question. What inspired you to pursue computer science in the first place? And did you always imagine yourself working in collaborative large-scale projects?
Good question. Well, I was a career changer. I started my career in civil engineering and project management, and I thought that I wanted to work outside. I had done some programming in undergrad. I wrote a C program that I failed, and I was like, I'm done with this. Um, but I found out later that I really liked putting spreadsheets together in Excel, and I was really good at that. And I built an early career, 3 or 4 years of that career, uh, building spreadsheets in Excel, and we were doing project management reports for billions of dollars worth of work on over 100 different buildings that were being built. And coming from managing that program and seeing like, hey, this could be better as a website. That's what inspired me to go into computer science. And I thought that I was going to do data science, but I found that I liked thinking about um, problems that were happening at the hardware level. So I did a hardware focused thesis. And then the jobs that I found in Chicago were all web. So I'm in web. But that's part of the reason why I started the consultancy was I didn't want to do so much web work anymore.
Great. So, Brandon is asking this. I think it's very interesting. You've balanced academia, industry, and consultancy. What have you learned about yourself by moving between these worlds?
Oh, that's deep. I like that question. What have I learned about myself moving between these worlds? I I think, and as somebody who's 40 years old and been, should be firmly a mid-career professional, um, the the thing that I learned about myself was I was going for some easy things. And I said, I just told you, I was like, oh, I really liked working with hardware. And then I went and took a web job. Like, I think the thing that I'm trying to improve about myself is being vocal about the personal goals that I'm trying to achieve, and then not trying, setting in motion the framework to make that happen. And that's why I started the company. Was I wanted to come out into the world and say, this is exactly what I want to work on. I'm looking for teams to collaborate with. I like being in the academic environment. I really respect people that you see on Nova. I don't know if you guys have that TV show, Science Friday. I want to work on stuff that is improving humanity instead of trying to nickel and dime taxi drivers. Um, you know, so starting the consultancy has been my way of kind of announcing to the world that I'm going to try something harder. I'm going to try something that I think is mission focused. Um, and I'm gonna kind of stick to it until I get there.
That's great. Okay, so last three questions.
Excellent.
Sarah, again, what do you find most rewarding about mentoring young developers or helping research groups scale their projects?
So I'm just starting on helping a research group scale their project. So I think what's going to be rewarding about that is seeing the Q composer be able to handle big load. Um, so I'm excited about getting that out. And Braulio, I am working on it. I started working on it this week. um, the uh, what do I find rewarding about mentoring? I like seeing guys grow. I at John Deere I worked with um two uh young people that were in what they called a development program, and they rotated through our team. And it was neat to see folks that were interested in software and being able to talk about ideas that they were interested in, trying to integrate that into the work that we were doing, learning from them what they saw in school and thought was interesting, and finding space for them to explore it. I was never a manager, but I was a lead, and being able to help people find assignments and things to work on that they thought that helped them align with their needs. I always got big satisfaction helping and then seeing folks succeed. that was the thing I liked about being a TA too, is when you finally saw a student get it, you try to explain something 4 different ways and then they finally get it. That was something I enjoyed. So I just find that personally rewarding, helping other people. I'm just like that kind of person.
Oh, good. Okay. What's one mistake you see many beginners make when starting a collaborative project, and how can they avoid it early on?
That is a great transition question. So
Yes.
besides the besides the making the mistake of going underground and building too much before you start showing people what you're up to, I think the biggest mistakes people make are in code hygiene and the style of code that they write. And that's the next topic I wanted to talk about. So let's move on to that.
Yeah, so before there's just one remaining question.
Okay.
Juna asked, when building new teams, what do you look for first? Technical skills or communication style?
Oh, dang. So I've never built a team myself. I've always joined one. Um, I have to say that if I was in the position to hire, and I would love to be in the position to hire, you can train, you can teach a curious person. So I would be looking for a communicative, responsible, and curious person. You can, one of my pet peeves in the current job market is folks are looking for a JavaScript engineer or they're looking for a Go engineer. They're not looking for a programmer. And or they're not looking for a problem solver. And I guess suppose you have to label what it is that you're looking for. But the the programming concepts between these language you can learn in a week. It's it's about the willingness to learn and and how much initiative you're going to take in learning for yourself. So you can train software engineering. You can't train collaboration.
That's great. So that was a very big moment for question. So I believe it's best to continue with your chat, your presentation, so we can move on.
I really appreciated the questions. This is the part of the presentation that I think I have a lot more to deliver. This next step, I'm going to kind of give a survey of some collaboration tools and why they're important. And but each of these topics themselves, except for the Kanban boards, which I'm going to show you first, are are things that you could easily, if we were to present it as a lecture, you could do a lecture series over, you could do a short course over half a semester. So I'm going to talk about Kanban here as a good tool for organizing your to-do list as a team, which is all it is. You can see that there are these, I don't have a pointer. On the left side of this slide, you see there's a swim lane called backlog. That's your to-do list. The swim lane next to it in progress, that's things that folks are actually working on. So this is a project I'm involved in for my neighborhood garden club. My colleague is working on the app header. I'm working on the calendar. When either of us finish that, we'll send it to each other to test. And then we can call it completed. So this is an organizational tool. There's a lot of different brands of it out there. This one is called Jira. But for the most part, they're free. It's really a helpful tool for just talking out what it is you're working on the day. The next thing I want to talk about, and this was what I would say is the biggest problem when starting a software project, is folks don't use Git. And especially you see a ton of memes about this regarding the vibe coding as well. So if you're vibe coding, like have the machine start a Git repo and make commits into the repo. But what is it? Git is a version control tool. I'm working on code that is in files in a directory. These are text files, right? I mean, or dot Java or dot JS or TS or C, you know, whatever programming language you're working on, but they're files that are eventually going to be slurped up by a compiler or interpreter and turned into code. When you're working on a team, several people are going to be working in that same directory. You don't have exclusive control over it. And Git as a tool helps you identify when you're getting ready to take your changes and put them back together. It helps you identify what those changes were and how and helps you disambiguate between things that might break. It does this through branching, and I kind of want to describe this in a scheme that people use called trunk-based development. And the idea is, if you see my drawing at the bottom here, there's a main branch, and this represents your software that is out in production. So, say I am working on my website and I want to post my slide deck, which I'm going to show this as an example down the line. I want to post the slide deck from today and I want to post it to my website. I start a branch that includes maybe the file for the slide deck and the markdown where I'm going to link to that. As I work in that branch, I'm going to make save points. So if I make a mistake somewhere along the line, I can revert them and go check back. It's just like playing a video game, like save where you were, and then if you lose your life, you can go back and try again. And then when you're done and you've collaborated with your team and they agree that you're done, you can merge it back to the main branch, and the tool itself can show you in a view that's like a side-by-side diff, what changed, what didn't change, and it's easier on your eyes to take a look at that. So absolutely use Git. There's other strategies in the trunk-based development, but the trunk-based development is popular today for good reason. It's pretty easy. But there's another one called Git Flow that people use too, and that's worth looking into. Then on top of Git, there are some hosting services that are that on top of the Git functionality that happens on your command line or in your IDE, they provide a few add-ons that are insanely valuable. One is just having backup of your code, right? You're on the bus, your laptop gets stolen, you lost all your work for the day, right? Well, if I had pushed my branch to Git and committed all my work before I left home, that's on the cloud. I can get it back. I mean, that's the obvious one. But the pull request is a really valuable tool for when you complete your work or you want an in-flight review of your work. You can generate one in the tool. It shows what you've added and removed. Your colleague can enter that pull request and then leave comments line by line about what they like or make suggestions. And they can approve it. And once you approve it, you can add it to your main line and run automations that either run their testing, deploy it out to your different environments. And there's other automations that run out there too. I mean, I got an email a couple weeks ago about a project I built 5 years ago, and they're like, you shouldn't use this server anymore. Like it's got a security vulnerability. And it's just, there's stuff out there that's just snooping the repos and looking for vulnerabilities. So there's a couple different providers of this service. GitHub, I think, is probably the most popular, but Microsoft is using that to train all the GitHub copilots. So when you make your code public there, know that AI is stealing it, if that's the way you feel about AI. Had a quick demo here. And I did most of it ahead of time just for brevity, but the window on the top right just shows how easy it is to check out a branch once you're in a repo. And then I modified some files and I checked them into the branch. And then the window below, I took the branch and I pushed it to the remote server. And from there, it created a pull request on the platform. And if all is well, you should be able to see the pull request live here. This is it. Can you see my browser window?
Yes, we can.
Excellent. So I have automation set up on this branch. I can merge the pull request. this is me, George at avondalian.com. If you want to write me an email, that's where you reach me. And what we'll see here is there's these actions. These are the automations. Here it's building my project, and it should be deploying it. And at avondalian.com, here in a minute or two, we should be able to see the slide deck up here, and you can download it. Yeah, so we don't need to watch it build, but if you go to avondalian.com, you'll be able to see it pop up here within the next minute or two. And that's a big thing that I think is important is I remember being in grad school and working on this hardware app and making a small change, waiting for it to compile, and just wasting 10s, 20s of minutes running make files, and it's like automate that. the repo can automate that. So this is the pull request I was talking about. What I wanted to show you is additions to the files were made in green, that you can click on the gutter there where the line numbers are, and when you do that, it opens up a dialog box and you can enter comments. So if you saw something that you thought was a mistake when you were reviewing your colleague's code, you can say like, hey, tell me more about this. I don't understand how this is working. Or have you tried testing the scenario? Just to have friendly conversation and see if there's ways to fix something that you see as weird. And you merge it, and the automations run. And by now, if you went to avondalian.com, you would be able to see download the pages. So Git, starting a new project, start with Git init command. Be working in a repo from the start, because you'll be able to undo and you'll be able to save your code someplace else. So they're awesome tools. I also talked about trunk-based development. I would read the user manual. There's a lot of features in there. But I would also recommend a book called The Phoenix Project. And that book's not just about version control tools. It's about the process of building a product. And it's kind of told in the parable of a company who's got a software project that's going really poorly. And then there's a hero that learns how to fix it. But it's a fast read, and it talks about automated testing, automated deployments, continuous deployments, and how they can really help move a project along faster. So with that, we've had a lot of good Q&A. We're getting close on time. I want to talk about design patterns a little bit. And when it comes to when you're doing homework assignments, it's really tempting to just put all of you're just learning and you're following tutorials, and you end up doing things like putting your user entry into the same function as something that's going to do math, and all your work gets kind of jumbled together. And I don't know if y'all have heard the term spaghetti code, but that's what folks usually say derogatorily about code that hasn't been broken down well into atomic pieces. But what you'll find when you're working through the pull requests and with other people is that you need to manage the change in your project well. And the solid principles help you get to atomic objects that don't need to change often and can be tested well. And the SOLID in here stand for single responsibility. Each unit of code, it doesn't have to be a class, although a lot of the resources for this are written about object-oriented languages. But this could be a module. This could be a function. Anything that you would consider like a closed unit of software should do just one thing. And to that end, once you write it, it should be pretty much permanent. You can write your code in a way where you can extend it. So say you had another function that you needed to add a variable or something, you can write a new function that calls the smaller one instead of going and modifying the smaller one. And this is important too when you're testing, because then you don't have to go and redo all of your tests. The list cost substitution one, it has to do with inheritance, and inheritance is really out of fashion. But if you have a subclass and a superclass, they should be interchangeable for the OO heads in the room. Interface segregation is the same as single responsibility in my mind. Like, you just don't do more than you have to. And dependency inversion, and I'm going to walk through an example of dependency inversion here. But this is what I was saying about, like, why are we using inheritance? If you compose your objects, it makes things a whole lot easier to test, and it helps you maintain to the single responsibility principle. For references on this one, there's a great book called Clean Code by Bob Martin. That one I thought was career changing for me. There's another book that I go to every once in a while, and it's just called like Software Engineering Design Patterns, and it's by the Gang of Four. If you look up the Gang of Four book, they go into more details and more examples than Clean Code does on how to compose software that abides by these principles. What's next? Yeah, so we were talking about that. Test-driven development. This is writing your tests first, but it's not appropriate for every project. Sometimes if you're not working on something that's mission critical, testing is gonna take up 2/3 of your development time. So but for a beginner, it helps you learn how to decompose your project and helps you stick to those solid principles. So, although, it's your team's decision or maybe your company's decision if they want to pursue this, but for a beginner, I think it's really helpful because it helps you identify when you may be violating the solid principles, which will then help you write code that's easier to collaborate over. And with that, I'm going to end it with a small example. This is a Java class, and it's a REST controller. So I'm not sure how many of y'all are familiar with REST, but it's a type of interface to your server, and a lot of web applications use it. And it's making HTTP requests to the server, and then it's responding with some information. It's popular, and if you don't know about it and you want to know about it, you should look it up, and I'd be happy to answer questions about that too. But anyway, there is a violation of the dependency inversion single responsibility principle here, and I'm curious if anybody sees it. And if you see it, open your mic and shout it out.
Thank you so much for your presentation, George.
Are we at the end?
I thought that you were.
No.
No.
Anyway, yeah, I got 2 more slides. So anyway, all I wanted to show was
sorry. No, please.
So yeah, all I wanted to show was this data provider is being instantiated inside of the method, which causes deep coupling. This becomes difficult to test because then you have to instantiate a database instance and then do integration tests instead of unit tests for the class. The solution here is to have the dependency injection framework initiate the provider and have it dependency injected in. And once you do that, your tests become easy because you can mock the data provider, which I don't have a pointer, so you can't see it, but you can see that on the right. You can define its behavior and then test that. The single responsibility of the controller is to validate the information and call the data provider. You don't have to test the actual path of returning the data from the database. With that, I had just a couple other tips for you guys, things to look into. Automate your testing. We already talked about that. Docker is a tool that's great for builds and deploying to servers. And that's a whole nother topic, but it's something that we should be looking into. You should think of your servers as cattle, not pets. You should be able to kill your server at any time, not feel guilty about it. And also, as you're setting up a project, make sure you're validating any data that's coming onto your server. And there's a lot of frameworks out. Whatever language you're using, a lot of the deep problems are already done. So like if you're in Java, use Spring Boot. If you're in JavaScript, use Express. If you're in C Sharp, use MVC. But there's a lot of the common software things you have to do. A lot of the work's already been done for you, so you can go in and implement the details and not worry about handling requests. And with that, I have time. If you guys do, I could answer a few more questions. And this is my reading list.
Thank you, George, for the delightful presentation. I believe we're up on time right now, and so far, I guess all questions have been correctly done. And thank you again for your sharing.